Okay, this is Computer Science 305. We're talking about Java 1, and we're going to continue on with class definitions. And so, a class definition, class is just a type, right? And so, you know, we've just got done covering expressions and statements. Now we can actually utilize those to actually build up a definition of a type. And so the one we're going to be looking at is called the con cell. Think about this as the same thing as a linked list in ML, like a list of integers in ML, right? So we're basically creating a linked list. It's a simple exercise that if we went through Computer Science 132, you should be very familiar with, except for maybe we're doing it slightly differently. Because what we're going to end up creating, and if you think about this, in 132, typically we create a linked list, a list with a node class, and then anytime we want to add an item to the list, we are modifying that list itself, right? We're adding new things to the list. In a cons cell-based list, we're always returning a new list, right? So essentially, our list is immutable, all right? And that's the key thing here. An immutable data type is one that cannot be changed, right? No operations change the underlying the object on which they were called. They will, if they do have to add something to it, they return a new version of it, right? Similar to how a string works, right? If we concatenate on a string, it returns a new string. So, in thinking about this, we can think about this, right? And I will actually construct this as we go along so we can actually see what's going on. Yay! So let's create the new class. Call it cons cell. So this is our class, right? And then we have in this class we have two fields, right? We have the private int head, which is the first item in the list, and then we have the con cell tail, which is the remainder of the list, right? As expected. Or null, right? It could be nothing, and so we expect that. So then we need to construct the list, right? So we have, we create a constructor. Takes in two parameters, the head, h, which is the contents of the current cell, and we add the parameter t, which is the next cons cell in the list, right? Or null. So we say public cons cell, right? As expected, we need to ensure that our constructor is of the same name as the type, right? They must match. Furthermore, the name of the Java file must match the type. So the main type in the class. We can have more than one type in a given file, but the main public type must match the name of the Java file. So we take in the two values, the int h and the cons cell t. All right, good times. And then we just say simply head equals h and tail equals t. Pretty simple, right? So note the difference of the comments, right? As it says here, when we follow with a /*, that is a doc comment, Java doc comment, and then the and it's also a multi-line comment. For your typical multi-line comments, it should be just /* to //. That will give you multiple lines. This is a special form of documentation comment. We can also put one up there at the top, right, for documentation. So this is actually used by a tool called JavaDoc, which produces documentation similar to what you see in the online documentation at like Java or any other library that you've ever used in Java. So, and apparently the framework has been updated for Java 9 and for 10 as well. Anyway, so furthermore, we also have the definition of a constructor follows, as it says there, it says it follows with an access specifier, so the public, private, protected, etc. that's telling us what how we who has access rights to call this constructor, followed by the name of the constructor, which matches the type name, and then the parameter list, right? And then followed by a compound statement. Note that it has to have the curly braces, right? The curly braces must be there. So that will let us know, unless we define this as abstract, but we're not going to talk about that until I think Java 2. So then we can create a couple more methods, right? So we said we probably need some accessor methods, which so we need one for the head of this console, and that returns the int contents of this cell, and we say public int get head, and we return head. Right? Pretty simple. Most of Java is a lot of this annoying boilerplate. Probably at I will create an extra special video that will teach you how to get rid of a lot of this, so you don't have to deal with it anymore. So this is the one for the get tail, which returns the tail of the list, right? Oh. So if you were using an actual IDE, what we could have done, which would be you can go up here and usually you have, like in IntelliJ, Eclipse, and NetBeans, you have the capability to just generate 90% of your code. So you can override methods, implement methods, delegates. You can generate all sorts of different things. Yeah, you can generate constructors, getters, setters, etc. There's lots of different things you can do. I'm not using that for most of it. Actually, I'll use it for this one. I think I can. Let's go and generate, yeah, alt insert would be, let's generate a setter for tail. Press OK, and lo and behold, saves ourselves from having to do too much work. Say it's mutator for the tail of this cons cell, right? Tail, the new tail for this cell. Yay! All right, that's done, right? So this mutator gives us a way to ask cons cell to change its own tail length. Note, like anything we did with lists and not like anything we did in ML, right? This is allowing us to mutate and makes it a mutable data type as opposed to what we saw before. All right, so I lied. It's not going to be an immutable type. Anyway, yay! So we're going to use this, right? And this cons cell gives us the capability to actually do things. And so what we want to do is we're essentially need to create an actual list based on this, right? So in order to do this, we want to create a new cons cell. We say A equals null. We can create another one, cons cell 2A, cons cell 1B, and that cons is up the list just like we did in ML, or with the sets in ML, if you will. Right, but unlike ML, we want our stuff to be object-oriented, right? And so where ML applies the double colon to a list, our Java should be able to cons onto itself, right? So instead of ML, which just creates a new list each time, we want ours to be able to build up within itself. And so, furthermore, ML has a special length function that applies to a list. We actually want the list to be able to figure out its own list, right? So we can't just typically use null for the empty list. We actually have to do something slightly more interesting. So we need to create another class, right? And this class we'll call intList, right? intList, which will then have, basically it just has the cons cell that is the container of the list itself. So we say private cons cell start, which is the head of the list head, or it could be null, right? So the empty list. And then we need a constructor, right? So we say alt insert, create a constructor, it takes in start, right? Which in this case would be our actual initial one or null, initial item or null. So we construct a new int list given its first con cell, right? So S is, our start is the first con cell in the list or null. Okay, good times, right? So what we're saying here is that essentially an int list contains reference to a list of con cell objects, which will be null if the list is empty, which we've been talking about this entire time, right? So now we have to add in the operation, right, to actually cons a list together. And so we'll do that. We'll say public int list cons int h, right? So where we're consing the given element h onto the current list and returning the new int list. So we do that. So h is the head int for the new list. So this is where it's sort of immutable, but not really. But anyway, and we return the int list with head h and the current list as the tail. Okay, good times. Basically, we just say return new int list new con cell h start. All right, looks good. So now an int list knows how to cons things onto itself as we want it to. It does not change, but returns a new int list with the new element at the front, right? So it is immutable. The int list is immutable, but unfortunately we defined con cell to be mutable by allowing us to change the actual tail. So interesting as that is. Finally, now we need to actually create a length function, right? The list should know how long it is, so we create a function get our method length, right? So at return this list's length, right? And so we say public int length, and we say int len equals 0, cons cell equals start, and we say while cell is not equal to start, oh sorry, null. So basically what we're saying is we're going to do this iteratively, right? Because that's how, as opposed to how we would do it in ML, which would be recursively. And the reason for this is recursion in Java is actually extremely slow because if we remember from the previous lectures when we were talking about memory management for variables, when we want to do recursion, we have to build up the stack. Well, that is essentially putting this entire method back on the stack frame every single time. Whereas we could just do it once and we can have this nice loop here which is going to handle that for us without having to create multiple activation records for a single method, right? In reality, if we were doing this in ML, ML is not going to necessarily create multiple activation records for the same thing because it uses tail recursion. It uses the same activation record over and over, just like what we're doing here with iteration. So we say len plus plus, and we say cell equals cell dot get tail. So basically what we're doing is we're walking the list at each piece at a time, looking at whatever's in the value is. Looking at, sorry, not the value, but we're adding one to our length as we traverse the actual list. And then finally we return the length, right? Makes sense. Now we know how to compute our length. Good to go. So now if we think about this, right, if we were doing this in ML, if we want to use this, right, in ML we said we create a value, we say it's equal to A is equal to nil. Create a second one, B. B is now 2 cons with A, and then val C is 1 cons with B, right? And then we can return essentially we could say X is equal to the length of A plus the length of B plus the length of C, which would give you the what would be 0, 1, 2, which make this 3, right? And we can do the same thing with Java. So we'll create a nice little Java file that'll derive this for us, right? And we just say public. I wonder if I can do that automatically. Oh, I can. Public, yep, static void main string args right? So we can have an executable function and simply say int list a equals new int list null int list b equals new int list a and int list. Oh, sorry. What am I doing? Pay attention, Isaac. This be a.cons 2 and int list c equals b cons 1, right? And then we can say int x equals a dot length plus b dot length plus c dot length. And then now we finally have gotten to a point where we actually can execute this, and we'll actually print it out. System.out.println x. Okay, we go ahead and run that. We don't need the terminal to do this. And we say, oh, we have the little arrow. Run driver.main. Should come up down here. And x is 3, as we expected. So, that's pretty good to go. All right, now we saw how to do all that. We're going to continue along, and we're going to talk about references and pointers. And then finally, we'll talk about getting started with the Java language system. Okay,